Hello friends, I am Dr. Siradul Fazi. I welcome you in my YouTube channel. Today in this video, I am going to talk about neighboring group participation. This is very important topic in organic chemistry. So, what is the definition of neighboring group participations? The direct interaction of the reaction center with a lone pair of electrons of an atom or with the electrons of a sigma or pi content with an parent molecule, but not conjugated with the reaction center. Friends, you can see the neighboring group mechanism in step 1. The first step, the neighboring group act Z as a nucleophile and pushes the leaving group X, but still remain attached to the molecule. So the formation of three-member ring. In the second stage, this three-member ring rupture and forming this product. So friend, in the second step, the external nucleophile Y displaces the neighboring group Z from the backside. Now friends, types of groups which are expected to display in NGP. So any group which has lone pair and pi electron showing NGP, neighboring group participation. You can see neighboring group participations here: sulfur lone pair of electron, nitrogen lone pair of electron, oxygen lone pair of electrons, Br lone pair of electrons, pi electrons and pi electrons. Now consequence of NGP. There are three consequences of NGP: enchimeric effect, retention of configurations, and syn substitutions. So I am going to show you or explain to you about the enchimeric assistance. Friends, you know, if the neighboring group participation result in an abrupt increase in the rate of reactions, then the phenomenon is known as enchimeric effect or enchimeric assistance. On reaction with water, both hexyl chloride and mustard gas give their corresponding alcohol. However, the rate of sulfur containing compound is much greater than the alkyl halide. So first one is less rate in comparison to the second one, mustard gas. So the rate of second is 700 times greater than one. Now friends, an increase in the rate is observed when mustard gas is hydrolyzed. Why? Because sulfur acts as neighboring group and displaces the leaving group, forming an intermediate which on hydrolysis give the products. So you can see here the formations of tricycle and then rupture of tricycle and forming the product. Now second important point related to neighboring group participation is retention of configuration. Retention of configuration. If the net change in a reaction is the replacement of ligand on a chiral center in a reactant molecule, and if in the product the attacking ligand occupies the same site on the chiral center as the replaced ligands, the reaction is said to occur with retention of configurations. A number of reactions are known in which nucleophilic substitutions occurs with retention of configuration. One of the important factors which lead to retention of configuration is neighboring group participation. So such reaction involve 2SN2 substitution. In first step, the neighboring group Z attack as nucleophile and pushes out the leaving group L, while the external nucleophile pushes out the neighboring group in consequent step. So, example of stereochemical consequences of NGP: deamination of L-alanine to lactic acid by the way of an intermediate lactone formed by the participations of carbonyl groups. So you can see the formation of three-member ring and then open. Now friends, I will talk about syn substitution, a type of substitution reaction in which the entering group takes a position on an atom adjacent to the atom to which the leaving group is attached. So you can see here the formations of tricycle and then rupture of this tricycle and forming this product. So friends, NGP may involve in the formation of rearranged product called syn substitutions. So you can see here slow and forming 5-member ring, and then this 5-member ring rupture and forming the open rearranged product and expected product. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.